Multiples, lowest common multiple. Learning intention, find the LCM, lowest common multiple of numbers using two methods, listing multiples and prime factors. Success criteria. I can list multiples and pick the first common one. I can use prime factors, highest powers. I can check the lowest common multiple is divisible by each original number. Example. Find the lowest common multiple of 3 and 7. So we start with the multiples of 3. They are 3, 6, 9, 12, 15, 18, 21, 24, 27, ... Multiples of 7 are 7, 14, 21, 28, 35, 42, 49, ... The dots indicate that the multiples go on forever. And notice that when we are listing multiples of a number, we always start with that number. So the first multiple of 3 is 3. The first multiple of 7 is 7, and so on. So then we just choose which is the lowest common one. And the lowest common multiple is 21. So the LCM is 21. If we count in groups of 3, we produce multiples of 3. So here we see we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 up as far as 21. And highlighted in red are all the multiples of 3. So the multiples of 3, the ones highlighted in red, are 3, 6, 9, 12, 15, 18, 21, 24. Counting in groups of 7, we produce multiples of 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 up as far as 21, ... And similarly, the multiples of 7 are highlighted in red. So we have 7, 14, and 21 highlighted in red. So the multiples of 7 are 7, 14, 21, 28, 35, ... Notice that 21 is the smallest number common to both sets of multiples. 21 is called the lowest common multiple, LCM, of 3 and 7. Lowest common multiple. The lowest common multiple, LCM, of 2 or more numbers is the smallest number into which each of the numbers divide. So 3 will divide evenly into 21 and 7 will divide evenly into 21 as well. So this is a much longer method than the previous example using the same numbers, but just to show you exactly where the multiples came from. Find the lowest common multiple of 8, 12, and 18. So now we have 3 numbers and we have a number that's quite big. So 18 is not a number that we would typically know the multiples of off by heart. But we go about it in the exact same way as the first example. So we get the multiples of 8. So they are 8, 16, 24, 32, 40, 48, 56, 64, 72, ... indicating they go on forever. Then the multiples of 12, 12, 24, 36, 48, 60, 72, 84, ... And then the multiples of 18, to get these, you can start with 18 because we always start with the number itself. And then you can just use your calculator and keep adding on 18. So we get 18, 36, 54, 72, ... So the lowest common multiple is 72. Factor trees can also be used to find lowest common multiple as follows. 1. Find the prime factors of each number. Step 2. List all the factors of the first number and include any factor from each other number that has not been included already. So let's say we want to find the lowest common multiple of 16, 24, and 30. So you can do it in the list method that we did in previous examples. It would just take a lot longer. So we get the prime factors of 16. So 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So the prime factors of 16 are 2 times 2 times 2 times 2. In the same way, 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So the prime factors of 24 are 2 times 2 times 2 times 3. And then 30. To get the prime factors of 30, we say 30 divided by 2 is 15, and then 15 divided by 3 is 5. So the prime factors of 30 are 2 by 3 by 5. So starting with 16, so we're going to write down all the prime factors of 16. So 16 as a product of prime factors is 2 by 2 by 2 by 2, or 2 to the power 4. And 24 as a product of prime factors is 2 by 2 by 2 by 3. So the 3 is highlighted here in red because that's different from the previous prime factors. So that's one that's extra. And then 30 as a product of prime factors is 2 by 3 by 5. So again, the 5 is highlighted in red because that one is not included in any of the previous prime factors. So the lowest common multiple of 16, 24, and 30 is going to be 2 by 2 by 2 by 2 by 3 by 5, which is 240. So just highlighting to show you where those numbers come from. So the first 4 2s come from the factors of 16, the prime factors of 16. And then that 3 comes from that 3, which is part of the factors of 24. And then that 5 comes from that 5, which is part of the factors of 30. So now we've included everything. So we have 2 by 2 by 2 by 2, by 3 by 5, which is 240. So you could have done this out using the list method, it just would have taken you much longer. So 240 is our LCM.